Percent composition. In example 1, we have CO2. The molar mass of the compound, 12.01 is the carbon, plus 2 times 16, which is the oxygen. You add those, and you get 44.01 grams over moles, and then the mass due to carbon is 12.01 grams over mole. And then the percent of carbon, you do 12.01 grams over mole divided by 44.01 grams divided by mole times 100, and you get 27.29%. Example number 2 is C6H12O6. The molar mass is 6 times 12.01 of carbon plus 12 times 1.01 of hydrogen plus 6 times 16 of oxygen. And you get 180 grams over moles. And the mass due to carbon is 6 times 12.01, which is 72.06 grams. Then you do the percent of carbon, and you get 72.06 divided by 180 times 100, and you get 40%.
A good description of what an empirical formula looks like would be H2O and sodium chloride. Magnesium oxide and cyclohexane wouldn't be good because they can be written in simpler forms. First, when solving empirical formulas, you take the percent sign and switch them to grams. Second, you will divide each element by its molar mass, located on the periodic table. Then you will divide each of the moles by the smallest number. Your answer should be very close to a whole number, like 0.5 or 0.94 from the next whole number, etc. The second example involves an extra step, but as for starting the problem, it is the same as the first example. You still start the problem the same, changing your percents to grams, then dividing by the molar mass on the periodic table. After you've gotten your moles, you will still take the smallest decimal and then you will divide it into the other one. If your ratios are not whole numbers, you must multiply. Say, for example, if you have 0.25 or 0.75, you multiply by 4. If you have 0.5, you multiply by 2. And if you have like 0.33 or 0.66, you multiply by 3.
Okay, so for example 1, you're given the empirical formula, and sometimes in molecular formula problems, you aren't initially given the empirical formula, you have to find it first, but since you just learned how to find the empirical formula, I'm not going to show you one like that. So the empirical formula for the first example is CH2O, and the mass of the compound is 180 grams per mole. Okay, so for this first step, you have to determine the mass of the empirical formula. So you take the mass of carbon, which is 12.01. Then you would take the mass of two hydrogens, which would be 1.008 times 2, because there's two of them. And then you would take the mass of oxygen, which is 16. And when you add all that together, you get 30.026. Step 2, you have to divide the mass of the compound by the mass of the empirical formula, which you just found right here. So the mass of the compound you're given, it's 180. And then the mass of the empirical formula, you're just going to take 30. And when you divide that, you get 6. Then the third step, you multiply this answer by the subscripts of the empirical formula that you're given. So you would do 1 times 6, which is 6. 2 times 6, which is 12. And then 1 times 6 again, which is 6. So then you take these answers, and those are your new subscripts. So it'd be C6H12O6. And that is your molecular formula. For example number 2, I went ahead and solved it. The empirical formula that you're given is C3H4O3, and the mass of the compound is 180 grams per mole. So for step 1, you have to determine the mass of the empirical formula. So you take the mass of 3 carbons, 4 hydrogens, and 3 oxygens, and add them together, and you get 88.062. And then you divide the mass of the compound by the mass of the empirical formula. So 180 divided by 88 is 2. And then you take this answer and multiply it by the subscripts that are given in your empirical formula. So 3 times 2 is 6, 4 times 2 is 8, and 3 times 2 is 6 again. And that makes your molecular formula C6H8O6.
So for the first example, I did CaCl2 times 2H2O, and you would write that as calcium chloride dihydrate. And this is another example, and it is sodium carbonate decahydrate, and you would write that as Na2CO3 10H2O. Now I'll show you how to make a hydrate formula, but to do this you need to know what an anhydrous is and the anhydrous is what is left after you heat the hydrate. You will usually be given the mass of the hydrate, the compound name, and the mass of the anhydrate. So this says first you subtract the anhydrous mass from the mass of the hydrate to find out how much water is lost. And then second, you change the mass to moles. Third, divide the moles of water by the moles of the compound to get the amount of water molecules, which becomes the prefix. And fourth, you write your formula and name. So this is the problem. So first I subtracted the hydrate from the anhydrous, which is 100 minus 48.8, and you get 51.2 grams water. Step 2, to change the mass to moles, I divided 48.8 by 120.38 because 120.38 is the mass of magnesium sulfate. Yeah, magnesium sulfate. And 51.2 divided by 18.016, I divided 2.842 by 0.405, and you get 7. And 7 is going to be the prefix, and you get MgSO4 times 7H2O. So the name for this would be magnesium sulfate heptahydrate. For our second example, I just went ahead and wrote everything out. It says 11.75 grams of a hydrate of cobalt 2 chloride is heated. 9.25 grams of anhydrous cobalt 2 chloride is left. Write the name and formula for this hydrate. So again, for step 1, you just subtract the hydrate from the anhydrous, and then you change it to moles, and you divide the bottom number by the top number, and you get 1.95. So for step 4, you got COCl2 times 2H2O, and the name for that is cobalt 2 chloride dihydrate. So the problem for you to try is when 4.89 grams of a hydrate of calcium sulfate is heated, 3.87 grams of anhydrous calcium sulfate remains. Write the name and formula. Now you know how to determine the formula of hydrate, but this shows you how to determine the percent composition of a hydrate from its name or formula. And it says for step 1, calculate total mass of formula. For step 2, divide mass of compound by total mass. Divide mass of water by total mass. And in the parentheses it says multiply by number of water molecules in hydrate. Step 3, multiply by 100 and write your percents. The problem is what percent of sodium carbonate decahydrate's mass is constituted of water. That whole number just comes from the formula sodium carbonate decahydrate. Like, that's the mass of that formula. So for the second step, you take the mass of H2O, which is 18.016, and you multiply it by 10 because it is decahydrate, which is 10. And whatever number you get there, you divide by 286.15, and you get 0.6296. You multiply it by 100, and you get 62.96%. Sometimes they may not just want you to know the percent composition of a hydrate, they may want you to know how much anhydrous will be left after it's heated. So to solve that, you do 100 minus the percent that you got in the first part of the problem, which I got 62.96%. So you do 100 minus that, and you get 37.04% Na2CO3. And if you divide that by 100, you get 0.3704. And you multiply that by 250 because it says in the problem 250 grams of the sample was heated. And you get 92.6 grams of Na2CO3. Problem says, what is the percent composition of iron 2 sulfate heptahydrate? If a 180 gram sample of this hydrate was heated, how much iron 2 sulfate will remain? After you find the percent composition, just make sure that you find the anhydrous that's going to be left.